In this section, we're talking about all types of application of derivatives. The first problem I ask you is to find the equation of the tangent line. Well, the way that you find the equation of the tangent line is you use the point-slope formula. That means you need a point and you need a slope. And your point-slope formula is y minus y1 equals m times x minus x1. Okay, so that's how that problem would begin. This particular one has a point at 3, 4. That's given to you. But we don't have a slope. So the way that you find the slope is the derivative. So your slope is your derivative. So in this particular problem, the derivative would be 3x squared minus 9. 3x squared minus 9. Now my point is x equals 3, y equals negative 4. Sorry, let me say that again. My point is 3, 4. So in order to find the slope, all I have to do is plug in the x value. The x value is 3. So it's going to be 3x squared minus 9. The x value is 3. So if we solve this out, we get 3 times 9 minus 9. So we get 27 minus 9, which is 18. And that is my slope. Once you find your point and once you find your slope, all you have to do is plug it into your point-slope formula. Y minus 4, because your y value is 4, equals 18 times x minus 3. You'll notice that all of your answer choices are y equals, so let's get y by itself. This would be 18x minus 54. To solve from here, I'm going to add 4 to both sides. Truly, this little piece right here is where more of my students miss the problem than any other place. They know the formula, they know the derivative, they miss this little sign right here. So please, please, please take your time with your signs. A negative 54 plus 4 would give you a negative 50. You'll see that 58 was one of your possibilities. If you picked the wrong sign or did the wrong operation, you would get 58, and don't pick that. So here's your answer. Be very careful with your signs. Okay, the second problem on this review deals with a tangent line again. It says where does the function have horizontal tangents? Well, a function has horizontal tangents when its slope equals 0. Now, it looks very similar to our last problem, so you'll have to know the difference between horizontal tangent and tangent of writing the equation of a tangent line. So this operation's really easy. You just take your slope and set it to 0. So my slope of this function would be 4x minus 12, and I'm going to set that equal to 0. So 4x would equal 12, and x would equal 3. So we say, great, x is 3, so it's not this one, and it's not this one. But then you get stuck. You'll say, I know the x is 3, but how do I know which of those 2 points it will be? Well, you have to remember, anytime I ask you to find y, you always use the original. So I'm going to take 3 and plug it into my original function. 2x squared minus 12x plus 16. Okay, when I put that in, I get a value of negative 2. So my point is 3, negative 2. The next application problem that we see is implicit differentiation. I'm asking you to find dy dx. Remember that every time you take the derivative of y, you put in a dy dx. Alright, so let's try this one. When I take the derivative of both sides, my first derivative is 3x squared. Then I have some bad stuff. And then my third derivative is 3y squared dy dx. And the derivative of 8 is 0. Okay, so let's stop there for a second. I have the 3x squared. That took the derivative of x with respect to x, so you didn't need an extra factor there. When you jump to the third term, you have a 3y squared. But since I took the derivative of y, I had to put a dy dx in that part. Okay, so in the middle, where I skipped it, your factors were 3x squared times y. So I need to use the product rule. The first factor is 3x squared, and the second factor is y. So d1 would just be 6x. d2, the derivative of y, would be 1. But remember, anytime you take the derivative of y, you have to throw a dy dx in there. The product rule says take function 1 times the derivative of the second, plus function 2 times the derivative of the first. And that's how that piece would look. Now once you get there, you want your dy dx's to stay on one side, and you want everything else to move to the other side. So I'm going to move this piece over, and I'm going to move this piece over. So 3x squared dy dx plus 3y squared dy dx would equal negative 3x squared negative 6xy. Get your dy dx's on one side and everything else on the other side. Okay, next you'll factor out a dy dx. To get dy dx by itself, you'll divide both sides by 3x squared plus 3y squared. Now, if you look at your answer choices, you'll see that that's not any possibility there. But if you look very closely, you'll see that you have a common factor. In the top you have a common factor of 3 and x, and in the bottom you have a common factor of 3. So since you have a common factor of 3 in the top and bottom, I'm going to factor out a 3. So dy dx would equal 3 times negative x squared minus 2xy, and 3 times x squared plus y squared. So the 3's cancel out, and your final answer is negative x squared minus 2xy, x squared plus y squared. Now be careful that you choose the right one. Okay, Okay, I'm looking for a 2xy in the top, so that can't be it, and that can't be it. On the top I have a negative x squared minus 2xy, so that's going to be this one. And that's how it would go.